Have you wondered how calculus could be applied to a free throw shot in basketball? Well, if we take some basic measurements and even get a video of me shooting the ball, we can really start to figure out how calculus can be applied. So in order to form the equation that we're going to use to derive and integrate for this calculus, we're going to need to find some basic measurements. So in a standard game of basketball, the goal is always 10 feet high, and the free throw line to the goal is always 15 feet. So by using an app on my phone, I'm going to be able to measure where I'm releasing the ball at to get the final unit measurement that we need for our equation, which is right here. So after we have figured out some of our measurements, it's time to plug them into this model to figure out our equation. So due to the arc of the basketball shot and how it goes up and then down, we need to use the negative x squared function. So we know that the height of the basketball rim is at 10 feet, but the ball must go a little bit higher than 10 feet in order to go into the goal, right? So then the distance from my shot to the basketball goal is 15 feet. And the release point of the shot is also 6 feet. So we know on a normal coordinate plane we have to be crossing at y equals 6 at this time, and then draw the function to where when x is equal to 15, y must equal a little bit over 10. So with knowing all this stuff, all these points, all these measurements, we're going to start to make the equation now. So for the equation, I found that this worked the best. So negative 1 over 2.87 x plus 3 squared plus 50. So now that we have our equation written out, which is what I found to be the best way to depict what the graph could possibly look like, we can start to take some derivatives and really figure out some maximums. So the first thing I want to do is just justify my reasoning for this problem. So to do that, I'm going to take a look. For this limit, I feel as if it would be appropriate to prove that when x is equal to 15, which is our distance from the goal, y is equal to a little over 10, to prove that the ball is going into the basket when it has reached 15 feet. So while we're taking our limit, we're going to do the limit as x is approaching 15. And to do this, we simply just plug in 15 for x. So after taking this limit and putting it into my calculator, I figured that as the limit, as x is approaching 15, our function f of x is equal to 10.04 to 8. And this number is just high enough over the goal to where the ball is entering the thing without hitting the rim and getting stopped. So to find the maximum of this value, we're going to start by taking the derivative of this function. So to do that, we do a simple chain rule. All right. So after some quick simplifying, we have ended up with this equation. And now we're going to set it equal to 0 and solve for t to find our values. So now that we have our equation, and after we've solved it for t, we found that t is equal to 8.8. But we can't forget our endpoints, which is also 0 and 15. So with these points, we can now find our maximum. But to do that, we're going to have to take all of our points and plug them back into our original equation. And then we can figure out which ones are max and which ones are min. So with our values, we figured out that our maximum occurred at 8.8, which our maximum height was 14.99, which was what we had inferred due to this 15 up here. So at 0, our value was 6, and that's because of when I released the ball, my hand was at 6 feet, so that makes sense. And finally, our end value, which is 15, which is where the distance from the free throw line to the basketball goal was, we have a value, when P is plugged into our original equation, we have a value of 10.04, which is when the ball would be entering the hoop. The last thing we're going to try to do to this equation is integrate it and find the area covered by the basketball on its way to the hoop. After doing some use substitution, we found that our equation, after integration, will look like this. And we don't have a plus c here because this is a definite integral, and we're evaluating it from 0 and 15. Alright, so after taking our integral and plugging our values, or our endpoints of 0 and 15, we found that as the ball is in the air, it covers a whole area of 188.6 square feet. And this can be modeled by this graph up here, as we start from 0, and as the ball travels 15 feet, and its slope, it goes like this into the basket, it covers 188.6 square feet of area. So I hope you enjoyed my explanation behind the calculus of a free throw, and that's what I like to call a slam dunk.